Okay, so this is the start of the sequences in series, video series. Anyway, so pretty much today we're going to be talking about the basics of the sequences in series, a little bit about the history, what it entails, and what it's used for. Well, sequences in series, the study of that began a very, very long time ago. I'm not even sure the date. It's just, arithmetic, counting has been around for thousands of years. I think even 6000 BC, we still had, systems of counting and things like that. And then number theory, is also very, very old. The Egyptians studied it. And even, today, after 2,000 plus years of studying number theory, we still have plenty of open problems that have eluded solution. Basically, so sequences in series are, you pretty much have, let's say we have a number 1, 2, and 3. That's pretty simple. You can add them up. 1 plus 2 is 3, and plus 3 again is 6, and all the way to infinity. And that can actually be written compactly, or in a smaller, quicker way, by saying n equals 1, and this fancy symbol is sigma, which stands for summation, and to infinity from from 1 to infinity right there, and then n, it would be all the numbers. So basically you just write down 1 and then 2, and then you stop at that the number at the top. This is the index, and that's just the stopping value. And so let's say we have a series like this. We have 1/2 plus 1/4 plus 1/8 plus 1/16. That can be written as n equals 1, and goes from 1 to infinity of 1 over 2 to the n. Because if we take 1 over 2 to the first, we'll have in 1/2. If we take 1 over 2 to the second, we'll have 1/4. And you can see that's that term. If we take 1 over 2 to the third, we'll get 1/8, 1/16, and so forth. And there are in the study of this, there are special versions of these series. This one right here is that one, the 1 over 2, and that is a geometric series. There are also, harmonic series and other series we'll get into. And then we'll talk about convergence and divergence in the upcoming videos. But basically, let's just do a couple of examples to really drive the point home of, to get intuition and a basic understanding for this. So let's say we have, just take off the cap of the marker. Okay, so let's say we have this series here from n equals 1 to 6, and of 2 to the n plus 1. Well, the way we'd start out doing this is we would do 2 times 1, because it's our first number right there. And so then we go ahead and add 1, and this gives us 2 times 1 is 2 plus 1 is 3. And then we have 2 times 2 plus 1 again, because wherever the n is, you substitute the next number. So this will be 5, and then 2 times 3 would be 6, and then 7. So basically, it would be, I'm just going to do a little shorthand, so it would be, 3, 5, 7, 9, 11, and 13. And basically, you just simply add all these up. So that's going to be 8. 8 plus 7 is going to be 15. It's going to be 24. This is going to be 35, and this is going to be 48. So the answer to this whole thing is 48. And all we really did was, Mike, I cut off a little bit. All we really did was we just substituted in this number for the n, and then all the numbers from this number to that number, the natural numbers. So, we have 1, 2, and then I kind of skipped 3, 4, 5, and 6, for a shortcut. So what if we had something like this? This is a little more complicated, but still nothing too involved. Let's say we have n equals 1 to 3 of 1 over 3n plus 2. We kind of start this the same way. So whenever we see an n, we just plug in our index values. That's the index value. So we start, with 3 to the first plus 2, and so we'll get 1/3 plus 2, and that's just going to be 2 1/3, which will be 7/3. Just doing a little bit of mental math, and then we'll have 1 over 3 squared plus 2, which equals 1/9 plus 2. So this is going to be 2 1/9, which would be 19 over 9. And remember, we're also going to be adding all these up eventually. Let me just kind of move over here. And then we're going to have 1 over 3 to the third plus 2. And that's going to be 1 over 27 plus 2. So it's going to be 2 and 1 27th, and if I'm not mistaken, it's going to be 55 over 27. Yeah, something like that. Okay, so, and basically I'm not going to go ahead and add them up right now. This is not really that important. But basically all you got to do is sum up this number, and this number, and that will get you the answer to this one. So just to recap, we plug in our first value for this and all the numbers that go to this value. And it doesn't really matter if the n is in the denominator or numerator or however the n is presented. And sometimes you even have two n's in the equation. So basically whenever you see an n, substitute in that number. All right, so this pretty much concludes the introduction to the sequence of the series. See you guys in the next